All right, good day to everybody. Again, today is Tuesday, September 22nd. We're going to be looking at today 5.0a.2, which is a continuation of what we are going to continue learning this week. Yesterday, we started talking about the three properties, commutative, associative, as well as distributive. That's going to help us with what we're really going to be learning about in fifth grade, and that is the order of operations. So today we're going to look at writing and interpreting a numerical expression in order to explain and model a real-world situation. As you can see here, of course, I have a chart, and we're going to talk about that throughout the week. PEMDAS, right? That's order of operations. Do not need to worry about that right now, but what we did yesterday, what we're doing today, it's going to help. We're going to understand it a whole lot more as we go through the rest of this week, okay? So let's take a look here while I go ahead and work through this problem. I'm going to go ahead and read this, and you could just read it along with me. It simply says, a drum line is made up of 14 fourth grade drummers and 12 fifth grade drummers. The fourth grade drummers stand in a line, and the fifth grade drummers stand in a line behind them. All right, so before I start going ahead and solving anything, we have to make sense of what it is that we just read, okay? So first and foremost, I know, okay, that there are 14 fourth grade drummers. There are 12 fifth grade drummers. The fourth grade drummers stand in a line. The fifth grade drummers stand in a line behind them. Okay, cool. So what can I take from that? I know that there's a drum line. I know that there's fourth grade, there's fifth graders, and they, of course, are standing in a line behind each other. Okay. Now that I made sense of it, let's go ahead and continue. It says, draw a visual model of the situation. Now, I'm not looking for a Picasso drawing. I don't need you to draw what you believe a drum line would look like. No, you just want to make a visual representation to help you understand this problem better. So I know we have fourth grade and we have fifth grade. So I'm going to go ahead and do this because I'm going to act as if like the drum major, right, is of course standing there. I'm going to say that's Mr. O'Neill, right? Again, I play the drums, so I'll be the drum major, okay? Now, it says that the fifth graders were standing in line behind the fourth graders. So let me go ahead and plug in the fifth graders, right? There's 12 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is fifth grade. Okay. They are behind now the fourth graders, which there's 14. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And that is fourth. Okay, cool. So now I've just drawn my visual model to help understand what is being said. It says, describe how you can represent how many more drummers are in fourth grade than in fifth grade. So key words right here, how many more? How many more fourth grade drummers are there than fifth grade drummers? Well, if you say that, okay, fifth grade has 12, that's what's being said, right? Fourth grade has 14, and we can see that here. We see that these two right here are the extra drummers, right? Now, we can basically describe, we know that fourth grade has 2 more drummers than fifth grade, and we see that based on this visual representation. If you were to, let's say, write a numerical expression, we could say that that could be 14 minus the 12, and that would leave us with 2. There's 2 remaining, 2 extra drummers that we have there, okay? So hopefully you can see that visual model and visual representation and understand what we just did, all right? So let's take a look at another problem. Here it has, build your understanding. Every day, Thora practices each page of this music 6 times. Okay, of course, I love the fact that these are questions involving the drums. Again, being a drummer, I can only appreciate it. Every day Thora practices, and I know from experience, ladies and gentlemen, and I just want to say, There are times if you want to play an instrument, you have to learn through reading a sheet music, right? This is a great visual. Even in middle school, you're going to need to know that, right? But knowing how many times you have to practice, that's where it might be tricky. So every day, thorough practices. In order to be great, you got to practice. Each page. Well, how do we know how many pages there are? Well, we can kind of look at this picture here, and we can see that there are 4 pages of music that she must, of course, practice with. Every day, Thora practices each page of this music 6 times. Okay? Draw a visual model to show the number of pages Thora practices each day. Well, we know that there are 4 total pages. It says she practices each of those 4 6 times. So let's see how we can draw this as a representation. I could say 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And hopefully you can see what exactly I'm doing. I know that there are 4 pages, and she practices each page 6 times. Okay? So here I have 1, 2, 3, 4, 5, 6. Okay, cool. So how can I possibly explain that? Now I know writing might be a little tricky, so I'm just going to type it in here. How could I explain what visual representation I just did? Well, glad you asked. Here we can say I can make 6 groups of 4, and that's what we created, 6 groups of 4 to represent 4 sheets of music being practiced 6 times. So that would be a great representation for what's being said. We see that there are 6 groups because you practice each page 6 times. So we can make 6 groups of 4, since there's 4 sheets of paper, right? Represent the 4 sheets of music being practiced 6 times. Okay, cool. Next, which operation does the situation, or sorry, which operation describes the situation? And how do you know? Well, instead of counting each one or skip counting, I can say, well, I know multiplying would probably be better. Why? Because there are 6 groups of 4, and that's representing 4 sheets of music she is practicing each day 4 times. Sorry, 4 sheets of lead 4 sheets of music that she is practicing 6 times each day. So I can then say the operation, and I'm sorry if you happen to see the screen blinking. If it is, hopefully it's not. The operation is multiplication because several groups of the same size. Oh, I gotta click return. Of the same size are being combined. Let me kind of minimize that. That way it can be seen a little bit better. Okay. All right. Now, before I answer B, okay, actually, let me do all of it, make it a little smaller. There we go. Before I do B, I want to go ahead and I want to read what is written here in yellow. It says connect to vocabulary. You can model a context mathematical using, let me read that again. You can model a context mathematically using a numerical expression. Now, here's what I would love for you to, of course, write down for notes. A numerical expression is a mathematical phrase that uses only numbers and operation signs. A numerical expression is a mathematical phrase that uses only numbers and operation signs. Does that mean a numerical expression should only have one number? No, it should not just have one number. The definition says it needs to have numbers and an operation sign or more than one sign. That's what makes it a numerical expression. Okay, let's answer B now. How can you model the number of pages, right? There are four pages of sheet music. How can you model the number of pages of music Thora practices each day using a numerical expression? Well, if we said there are 4 sheets of music and there are basically 6 times she practices this, and there are 6 groups of 4, we can possibly say that it could be 6 times 4. Great, short, easy way of saying that. 4 sheets of paper. She practices each of those pages 6 times every day. Right? We don't have to worry how many days she's practicing, but it says every day she practices each sheet of paper 6 times. It's a lot of practice. So we can say basically in one day she does 24 practices, right? Or 24 times she's doing the music, because 6 times 4 is 24. But we don't need to solve it. We're just creating a numerical expression. All right, C. It says describe what the numbers and operation sign, in your numerical expression represent. What does that 6 times 4 represent? We could basically say the 4 represents the number of pages of music and the 6 represents, oh, I clicked enter, sorry. And the 6 represents the number of times she practices each page. Now, I'm not done. It says describe what the numbers and operation sign in your numerical expression represent. So the 4 represents the number of pages of music. The 6 represents the number of times she practices each page. And the multiplication sign, you want to make sure you answer every question completely. The multiplication sign represents the combining of 6 groups of 4. And that, ladies and gentlemen, is your full description of what you need to have regarding this particular question. Okay? Again, I hope this has been helpful for you. Okay? Tomorrow, of course, we're going to just keep expanding more and more each day into the order of operations. With being able to work on an order of operations, it's best if you create and write a representation, so that way when you see it, you can understand it better because you have already created them. All right. So go on, keep practicing this stuff. And again, strive for greatness.